So this is lesson 3.3. We're taking a look at solving systems of linear inequalities. We looked at graphing one inequality in chapter 2. Now we're going to put a couple of them together. So we're going to start by graphing y is less than or equal to 7. Remember, when you see the equation of a line where it's just an x or just a y, it's a horizontal or a vertical line. So if you don't remember which, you can start plotting a few points. We have a y-intercept, so I'm going to graph my y-intercept of 7. And then think of some other points where y equals 7. Remember, we're graphing the line y equals 7. We're going to shade the inequality y is less than or equal to 7. So some ordered pairs that work: 2, 7, 10, 7, negative 3, 7. So we can see that it's a horizontal line. And because it's an or equal to, it will be a solid line. And again, use the whole graph. Now we've got 3 inequalities that we need to see all of them intersect. So you're going to want to use the slopes when you're graphing the other 2 lines and extend them for the full space that you have. So my second line, my y-intercept is an integer, but my x-intercept is not. So I'm going to go ahead and put this into slope-intercept form. I'm going to add y to both sides and subtract 3. So I've got 2x minus 3. So I'm starting with my y-intercept at negative 3. And then my slope is a positive 2, so I'm going to go up and to the right. And of course I want to extend this until I can see where my lines meet. But I want to extend it the other way as well because I don't know where it will intersect that third line. Also, this line is dotted because it's just a less than symbol. And don't forget arrows at the ends of your lines. All right, last equation. Both my x and y-intercept are integers. So if I substitute 0 for x, I get a y-intercept of negative 6. And if I substitute 0 for y, I get an x-intercept of negative 3. But I also want to find my slope so I can kind of get my line going in the correct direction. So if I subtracted 2x from both sides, my slope would be negative 2. So I'm just going to fill in a couple of extra points here. And again, this line is dotted as well because it's just a greater than symbol. And arrows at the ends of my lines. So what I do, obviously, is I graph my lines first, and then I shade at the end. Some people shade everything that's true for all of them, and then kind of use the different colors overlapping as their final solution. I think that looks a little messy and a little confusing. So I only shade where they are all true, similar to when we're graphing on a single number line. So the way that I do that is I use arrows instead of shading, and then I only shade the region where all of my arrows are pointing. So my y is less than or equal to 7, obviously that will be shaded below my line, and I just put arrows in all of the regions so that I can, like I said, see that one region where they're all pointing to. My second line, if I substitute 0 for x and y, I get 0 is less than 3, which is true. So for my green line, I'm going to be shading towards the origin. And then for my blue line, substituting 0, 0 is greater than negative 6 is also true. So I'm going to shade towards the origin on my blue line as well. And we can see that where the red, green, and blue arrows are all pointing at each other is this center region. So this is the only spot that I will shade. Remember, all of them have to be true. So we've got, for example, right here, we have 2 of the arrows, but not all 3, so we would not shade that region. Same for the other ones. We've got 2, but not all 3, so those would not be considered part of the solution. It has to be where all 3 of our inequalities are true. And finally, classifying our shape, hopefully we recognize a 3-sided figure as a triangle.